I'm Anil Kumar, and here is a question from Unit Test 2 Advanced Functions Rate of Change. Matthew leaves his house to go for a run. He ran at a constant speed of 10 kilometers per hour for 30 minutes. The path sloped upwards, so he ran at a rate of 6 kilometers per hour for 15 minutes. At the top of the hill, he increased his speed to 8 kilometers per hour for 30 minutes. He stopped for 15 minutes to rest. Finally, he ran at a constant speed of 10 kilometers per hour for 30 minutes. Sketch the graph of Matthew's distance versus time. What is Matthew's average speed during entire time he ran? What is Matthew's average speed between 15 and 45 minutes? And what is Matthew's instantaneous speed at 60 minutes? You can pause the video, sketch the graph, and then look into my suggestion. Now, in these distance time graph questions, what you need to do is select an appropriate scale. That's kind of most important to start with, right? So what we notice here is that we are given speed in kilometers per hour and time in minutes, right? So which is like most of them is 15 minutes and 30 minutes. So what I will do is I'll take every small unit along the horizontal as time in hours, right? Now an hour has 60 minutes, and since we are interested in 15 and 30 minutes, I'll use one small division as 15 minutes. So 4 of them will make 1 hour. So 1, 2, 3, 4, that is 1 hour. 1, 2, 3, 4, second. 1, 2, 3, 4, third hour, right? So these are times in hour. 1, 2, 3, and so on. Now speed is kilometers per hour. So in 30 minutes we expect a distance of 5 kilometers for the first run. So, and here we have 8 kilometers per hour. We expect 2 kilometers there. Now we can even out and we can have this small division as 2 kilometers each. So we'll have distance in kilometers along the y, which is dependent on the speed. So every unit I will have as 2 kilometers. So it is 2, 4, 6, 8, 10. So that becomes 10 kilometers, right? 2, 4, 6, 8, 10. So that makes it 20. 2, 4, 6, 8, 10. That makes it 30, right? So like that, I have distance in kilometers along the vertical axis, right? Now we will plot the points. So I'll take a lighter color to plot the points, because while doing the calculations we may go wrong, right? So the first, he ran at a constant speed of 10 kilometers per hour for 30 minutes. So it is 10 kilometers an hour. So in half an hour it's going to be 5 kilometers. So in first 30 minutes he ran 5 kilometers. So 30 minutes is kind of here, and 5 kilometers, 2, 4, 6, so in between. So we are starting with a point in between. There it is, right? So this is the first lap. So it goes from 0 to 5. The path sloped upward, so he ran at a constant speed of 16 kilometers per hour for 15 minutes. 6 kilometers per hour for 15 minutes. So 6 kilometers in an hour. Half an hour will be 3, and 15 will be half of 3, that is 1.5, correct? So 1.5 we are going to add to 5. So that is 6.5. So 6, and they're very close to that. So this is 6.5, and it takes 15 minutes, so one division, right? So that is the point. Now this point is at, I should say, 45 minutes. That means 0.75. I'll not mess it up anyway, but I'll just connect this point, and this is at 6.5. Okay. At the top of the hill, he increased his speed to 8 kilometers per hour for 30 minutes. That means half of this, 4 kilometers. So if I add 4 kilometers to this, it becomes 10.5. And that is next half an hour. That means 2 divisions from here, right? So 1 and 2. And 10.5 is close to 10, so that is the next point for us. So these are our points. So constant, we have to connect it with a straight line. Correct. As far as time goes, we have done 1 hour 15 minutes. So that is correct. 1 hour and 15 minutes. He stopped for 15 minutes to rest. So 10.5, we are stopping for rest. Finally, he ran at a constant speed of 10 kilometers per hour for 30 minutes, right? So let me say comma here. 10 kilometers per hour in 30 minutes means 5 kilometers in next half an hour, right? So 5 means 15.5. Next half an hour means 2 divisions, right? Now 15 we add, we get 25.5, okay? So, sorry, 5 we add and we get 15.5. So in half an hour, 15.5, so it is 10, 12, 14, this is 16, so close to 16. Okay, so that is the final stage. This is at 15.5, right? That is the maximum distance Matthews has been to. So that is the graph which we have drawn. I could have actually stretched it a bit more, taking each as, one division, right? Then it'd be easier for me. Anyway, it is not bad. Sketch the graph. That is the graph for us. What is Matthew's average speed during entire time he ran? Now, how will you find average speed? Average speed is distance covered by time taken, right? So you can see 15.5 is the total distance, right? So 15.5 is the total distance since we started from origin, which is 0, divided by total time taken, right? So it shows 2 hours for us. But let's count it. 30 minutes and then 15 and 30. So 1 hour 15 minutes, 1 hour 30 minutes, and then that is 2 hours, correct? So total time is 2. So that gives us this is in hours and that is in kilometers. So we have average speed of 15.5 divided by 2, right? 2 hours. So that is the answer, which is 7.75. So we can write down the answer here, 7.75 kilometers per hour. What is Matthew's average speed between 15 and 45 minutes? So 15 minutes is this point. Every unit is 15 and 45 is right there, right? So these are our points. So we can find 15 from here also because the graph is not that good. Half of 5, 2.5, right? So this is 2.5 for us. So this is 2.5. And 45 minutes, we knew this is the 45-minute mark, right? Which is 6.5. So it is 6.5 minus 2.5 divided by the time taken, which is 45 minus 15 divided by 60, because we are talking about time in hours, right? So that is 30 minutes, which is half an hour, right? So divided by half, correct? So that gives you the average speed between 15 to 45. So that is 4 times 2 is 8. So it is 8 kilometers per hour. So that is how you can find this average speed. Okay. Now next part is, what is Matthew's instantaneous speed at 60 minutes? 60 minutes means an hour, and that is, you can find out from here. After an hour, it is 8 kilometers per hour, right? It's already given to us. We don't have to find this slope. We already know this, right? Now, after, at the top of the hill, he increased his speed to 8 kilometers per hour, right? So we need to find 60 minutes means 1 hour. At that time, he's running at the speed of 8 kilometers per hour. So this is 8 kilometers per hour. It is the slope at this point, which will be 8 kilometers per hour, right? So that is how you can answer such questions, right? So as you learn from here, if I would have found distance, if I would have made a table to start with, I would have known the highest point, and that would have helped me to make a better scale, but this is not bad either, right? So that's how you can do it. I hope you find it easier to do like this. I'm Anil Kumar. You can subscribe and learn a lot about functions and advanced functions. Thank you.